Yo, what's going on? I am back with another video for you. This is actually over the 4-3 notes, trigonometric functions on the unit circle. So let's get started. The unit circle is a tool used for understanding the sine and cosine angles. Angles are found on the right triangle. The x and y coordinates of a unit circle represent the sine value. Sine is y, guys. All right, sine is y. All right, so it's important you know that. Cosine is x. Sine is y. Cosine is x. All right, for the angle of theta. The unit number circle, the name unit circle comes from the radius of the circle, which is 1 unit long. All right, 1 unit long. We'll talk about that. All right, right here, as you can see, here's your unit circle filled in. You have your plate. All right, it looks like this, except you didn't fill in the coordinates, which I want to talk about the coordinates right now. You'll eventually fill these in on your circle, on your plate. But right here, starting at 0 degrees. All right, if you look, it's called unit circle because it's 1 unit, as I just mentioned. So this point right here, you saw this is the x-axis, so I went over 1 unit 1 to the right, so that's 1, 0. I didn't go up or down. So 0 degrees is at the coordinate point 1, 0. 90 degrees, you go up 1. You didn't go left or right, so you go up 1, which is your y value. So 0, 1. 180, all right, or pi, is negative 0, 1. All right, and then down here 270, 0, negative 1, because I went down. I didn't go right or left. All right, so there's no x value. Okay. Or 0 is the x value. And then 360 again is back at 1, 0. Here's your basic rules right here. Sine of t, in a sense t, but sine of theta, all right, is y. Cosine is x. All right. Cosecant is 1 over y because they're inverses. Secant is 1 over x because they're inverses. All right, you know if you have y over 1 is the same thing as y, right? You know this is y over 1. All right, is y. So sine is y. Well, the inverse, if you flip it, is cosecant 1 over y. All right, that's a terrible y, but 1 over y. All right. Tangent is y over x, sine over cosine. And cotangent is x over y, cosine over sine. All right. Values in the denominator cannot be 0. All right. Values in the denominator cannot be 0. All right. The radius of a hypotenuse of a right triangle. The radius is the hypotenuse of a right triangle found on the unit circle. Since the radius is 1, the hypotenuse, and the ratio is a value, is a 1 value. All right. All right, using the unit circle. Here, let's do it like this. All right, so what I decided here to do is to split the screen so you can see all the coordinate points. Right on number 1, all right, with the directions here, it says, you can see it on your paper. If you have your paper, it says use a unit circle to find each value. All right, when using the unit circle, the answer must be in exact form. All right, in exact form. I don't know what's wrong with that. There we go. In exact form, like in exact. All right, in exact form. So, right, sine of 7 pi over 6. Well, I go to my unit circle. All right, I find 7 pi over 6, which is right here. Now remember, sine is your y value. Cosine is x. Cosine is x. Sine is y. So sine of 7 pi over 6 is negative 1/2 right here. All right, so sine of 7 pi over 6 is negative 1/2. All right, cosine of pi over 3. All right, cosine is your x value. So cosine of pi over 3, cosine is your x value. All right, it's your x value. So I go to pi over 3. I look right here. The x value is right there, 1/2. All right. Now for this next example, tangent of 4 pi over 3. Tangent of 4 pi over 3. So tangent, if you remember, tangent is y over x. So I go to 4 pi over 3, which is right here. All right, x and y. And then I go to do tangent. So for tangent, we've got to do y, negative square root of 3 over 2, divided by negative 1/2. Okay? Now, the negatives are going to cancel. And then if you remember with fractions, you've got to use the keep, change, flip method. Keep, change, flip. And what that means is you keep the top value. All right, you change from division. See, that's a division bar. You change it to multiplication and you flip the bottom right there, right? So what I do is the 2's are going to cancel and I have square root of 3 over 1, which is square root of 3. So tangent of 4 pi over 3 is going to be radical 3. All right. Now let's look at some more examples. For this example right here, number 4, excuse me, I went too far down. Number 4, secant of 270. Well, if you remember, here's 270. Secant is 1 over x, or 1 over cosine. So we have 1 divided by 0. All right, 1 divided by 0, because the x value is 0. So that is going to be undefined. All right. Secant of 270 is undefined, okay? Because remember, you can't have 0 in the denominator. All right, cosecant of 11 pi over 6. Cosecant of 11 pi over 6. So 11 pi over 6 is right here. You want cosecant. Well, cosecant is 1 over y because it's the inverse of sine. So the y value here is negative 1/2. So we have 1 over negative 1/2. And again, keep, change, flip, keep the top, which is 1. Change to multiplication and flip the bottom, negative 2 over 1. So 1 times negative 2 over 1, well, that's 1 times negative 2, which is negative 2. All right, so cosecant of 11 pi over 6, all right, is going to be negative 2. All right, cotangent of 210. Cotangent, if you remember, is x over y. So we find 210, which is 7 pi over 6 right here. So we got to do x over y, which is negative square root of 3 over 2 divided by a negative 1/2. Again, the negatives cancel, and we keep, change, flip. Keep the top, change the multiplication, and flip the bottom. 2 is a cancel out, and I'm left with radical 3. All right. All right, sine of negative 180. All right, here's, well, remember negative 180, you got to go this way. So right there, there's negative 180. All right, which is still 180. So sine of negative 180, sine is the y value. So 0. So sine of negative 180 is 0. All right. Cosine of negative 240. So 240 is here. So this way. So negative 240 would be this way. Really, all you gotta do is flip it, guys. If 240 is here, negative 240 is right here. All right. And you want the negative, cosine, so that's your x value. So negative 1/2. Negative 1/2. Cosecant. For cosecant, we have, let's see what this says. 15 power 4. So look, listen, for 15 power 4, guys, that's not on the unit circle. So what I'm going to do is, first I'm going to find an angle that's coterminal to this that's on the unit circle. So 15 pi over 4, I'm going to subtract 2 pi, which is 360. All right. So I need common denominators. So if I make this a 4 down here, I got to make this a 4 up here. So that gives me 15 minus 2 times 4 is 8. So 15 minus 8 is 7. So 7 pi over 4. Now that is on the unit circle. All right, 7 pi over 4 is right here. All right, 7 pi over 4. So when you're looking for cosecant, cosecant is 1 over, there we go, 1 over y, which in this case, 1 over negative radical 2 over 2, which we simplify, we keep change flip to 1 times 2 over radical 2, well, negative, right? So now 1 times this is still that, negative 2 over radical 2, which we then need to rationalize. And how we rationalize that is move the radical to the top, keep the number from the radical at the bottom. All right, move the radical to the top, keep the number from the radical at the bottom. So cosecant of 15 pi over 4, which is coterminal to 7 pi over 4, is this. All right, negative 2 radical 2 over 2. You got to find the exact value, guys. You can't just punch that in your calculator. All right, exact value, not the approximation. The calculator will give you a decimal, which is an approximation. And one more, tangent of negative 585, which we need to find a coterminal angle for. So if we took 585 or negative 585 and we added 360, that'll give us 225. So a coterminal angle to this is 225. Well, negative 225, excuse me. So 225 is right here. So that means negative 225 would be right here. All right. And this, again, it's a mirror image. If this is positive 225, then negative is up here. Like this is 120, then negative 120 would be right here. You know. So it says tangent. So tangent is y over x. So we have radical 2 over 2 divided by negative radical 2 over 2. All right. It's the same thing over itself, right? So that's just 1. You still got that negative, so negative 1. So tangent of negative 585 is negative 1. All right. All right. For this part, right, flip over. Right here it says definition of a trig function of any angle. R is the radius of a circle. All right. R is the radius of a circle. So R equals x squared plus y squared. All right. So sine of theta equals y over r, whatever that radius is. Cosine is x over r. Cosecant is r over y because it's the inverse. Secant is r over x because it's the inverse of cosine. Tangent is y over x. Cotangent is x over y. That doesn't change. All right. These are the same ratios from the unit circle, but the r value is not 1. All right, the r value is not 1. So in the unit circle, the r value is 1. You know, which we talked about it. So right here it says, given that the point lies on the terminal side of angle theta, find the value of all 6 trig functions. So with this example right here, here's what you got to do. Think about this, all right? If I had a unit circle, the point 4, 3, positive 4 up 3 would be over 4 up 3, right? So that's where I'm going to draw my right angle. And you always draw theta out of the origin. Theta always, I don't care which quadrant you draw your triangle in, theta will always be in the origin. All right, if I drew one down here, theta would be out the origin. All right, if I drew one down here, theta would come right there by the origin. Theta is never Like, I've seen this in the past. Kids are like, oh, that's theta. Absolutely not. Theta always comes from the origin. That's why we have a radius. All right. It came from the origin. All right. It can't come from one of these other angles. That's wrong. All right. From the origin, from the origin, from the origin, from the origin. All right. Now, let's look at this problem again. 4, 3. Right 4, up 3. All right. I don't have to really count out the numbers. All right. So there's theta. So now, if you think about a point, I went right 4. I went up 3. So now what I'm going to do, I need to find this side over here. I don't know what that is, but it's okay. All right. I'm going to use Pythagorean theorem. So a squared plus b squared equals c squared. Well, I have my side values. I don't have my hypotenuse. My hypotenuse is always c. So I have 4 squared plus 3 squared equals c squared. 16 plus 9 equals c squared. That's 25, which equals c squared. And then you take the square root on both sides to get rid of the square. C equals 5. So the hypotenuse right here is 5, guys, okay? 5. Now, I can find my 6 trig functions. And here we go. Sine of theta. Opposite. Oh, wait. Let's label our parts. Opposite. See, draw your line straight across. Opposite. That means 4 is adjacent. And 5 is my hypotenuse. So sine, if you remember, is opposite over hypotenuse. So 3 over 5. Cosine of theta is adjacent over hypotenuse, or 4 over 5. Tangent of theta is going to be opposite over adjacent, or 3 over 4. Cosecant, the inverse of sine, is 5/3. Secant of theta, the inverse of cosine, is 5/4. And cotangent, the inverse of tangent, is 4/3. All right. Now let's clear this off. Let's do another example. The setup is just, once you get past the setup, guys, all right, it's not bad at all. Again, -2, -2, -1, right? -2, -1, which means, again, theta comes out the origin. Now I got to find my hypotenuse. All right, these are side measures. So -2 squared plus -1 squared equals c squared. A squared plus b squared, c squared. Well, that's 4 plus 1 equals c squared. 4 plus 1 is 5 equals c squared. Square root. C equals square root of 5. And that's okay, guys. C is square root of 5. That's the radius. So now, let's label our parts. Here's theta. Draw your line. Opposite. That means this is adjacent. This is your hypotenuse. So, sine of theta, opposite over hypotenuse. 1 over square root of 5, which we rationalize, move the radical to the top, and leave the number from the radical at the bottom. So, square root of 5 over 5. All right, 1 times square root of 5, square root of 5. Cosine of theta. Cosine of theta is adjacent over hypotenuse, which again, rationalize, move the radical to the top, leave the number at the bottom. Tangent of theta, opposite over adjacent. -1 over -2, which reduces to 1/2. Cosecant of theta. That's the inverse. Look at the originals. Look at the originals. So flip this. Square root of 5 over 1. Square root of 5. Secant. And that'll make your life easier. Look at the originals. When you have radicals, look at the originals. Secant, the inverse of cosine. Invert that. Negative square root of 5 over 2. Alright, and then cotangent. Flip it. Flip 1/2. It's 2 over 1. Which is 2. Those are your 6 trig identities right there. Alright. Alright. Moving along. Next right here it says if one of your ratios for a trig function is known and you know what quadrant the angle is in, you can find the remaining ratios. Alright, so check this out. This right here represents the quadrants, alright? And quadrant, everything's positive. Alright, everything's positive. Positive x, positive y. Over here, only sine and cosecant are positive. Because think about it, sines are your y values. So sine is positive, cosecant is positive. Over here, tangent is positive, cotangent is positive. Because sine and cosine are negatives, and negative over negative is positive, right? Because this is y over x, and this is x over y. And down here, cosecant, cosine, is positive, secant is positive. All right, but listen, guys, you can memorize this very well. Memorize it. I, for one, just use these rules. All right, so I kind of do what we did with the other problem where we figure out what quadrant is in by making a triangle. So cotangent, if you remember, cotangent is greater than 0. So if cotangent is greater than 0, that means it's positive. All right, so that means cotangent is positive, and then we have right here what sine is 5 over 7. So sine is positive. So any number greater than 0 is positive, right? Like think about a number line, you got 0. If you go to the right, anything greater than that, 1, 2, 3, 4, 5, 6, it's positive. So we have a positive cotangent, positive sine. That means we're in the first quadrant. Everything is positive. All right, so we have sine is, this is your y value. All right, or theta, opposite 5, hypotenuse 7. Now we got to find this value using Pythagorean theorem. That's a squared plus b squared c squared, or 5 squared plus b squared, that's b, equals 7 squared. All right, solve this out. 25, 49, subtract the 2, b squared equals 24. If you take the square root, that's a b, guys, sorry. If you take the square root on both sides, you get b equals square root of 4 times square root of 6. The square root of 4 is 2. So b equals 2 radical 6. Like that. So now that we have the triangle set up, guys, solving this is just like what we did earlier. All right, we know what sine is. Sine is 5 over 7. All right, cosine. All right, level out parts again. This is opposite, adjacent, and hypotenuse, right? Hypotenuse. That's our y value, opposite. So anyway, cosine would be 2 radical 6 over 7. And then tangent is going to be 5 over 2 radical 6, opposite over adjacent, which we most rationalize. 5, move the radical to the top, and then at the bottom down here, leave the number at the bottom. So it's 2 times 6, which is 12, like that. All right, that's tangent. Cotangent, well, here, cosecant. Cosecant is the inverse of sine, so 7 over 5. Secant is the inverse of cosine, so 7 over 2 radical 6, which again, move the radical to the top, and then multiply the two numbers at the bottom. So 6 times 2 is 12. So this is secant. And then one more, we have cotangent, which is the inverse of this one. Flip the original. So you have 2 radical 6 over 5. Like that. Alright. There's one more right here. Let's see. Do I have time to do it? Yeah, I got time to do it. So let me do this. Oops, sorry about that noise. Sorry about that noise. Alright. Let's do it one more time. Alright, for this problem right here. Let's see. Let's erase. Need to erase. Alright. For this problem right here, sine is less than 0, which means sine is negative. Alright, sine is negative. So where are the sine values negative? It's in one of these two quadrants down here. Alright, yes, if you memorize this chart, great, memorize it. Alright, I'm going to be 100% honest. I've never memorized that chart. I just use logic. Sine is less than 0. Remember, sine is your y value. So my y values are down here if it's negative. They're one of these two quadrants. But tangent is 5 over 12. Well, if you remember, this is sine over cosine. Alright, so we know sine is negative, which is down here. Alright, and then this is positive. So it's in the fourth quadrant. Right? Negative sine. Alright. And then these are positive, so that means that needs to be negative too. Negative over negative. Alright. Actually, so it's not in that quadrant because that's positive. It's negative over negative, so it's over here. Alright. So again, you can memorize the chart. Alright, which tan is positive over here. Negative sine, positive tan. Alright. Negative sine, positive tangent. This quadrant. So we have negative 5 because this goes down. Negative 12, we got to find the hypotenuse. Negative 12 squared plus negative 5 squared equals c squared. Got to find the hypotenuse because that's y over x. All right, y, x, we still got to find the hypotenuse. So 144 plus 25, all right, it's going to give us 169, right? And then the square root of 169 is 13. So this is 13. So now we have that. If we label all our parts, opposite, adjacent, hypotenuse. And we find our 6 trig functions. So sine is going to be negative 5 over 13, which they told you sine is less than 0, which means it's negative, right? Cosine of theta is negative 12 over 13. Tangent we know is negative 5 over negative 12, which is a positive 5 12, which is what we got. Cosecant, the inverse of sine, is going to be 13 over negative 5. Secant, the inverse of cosine, is going to be the inverse of cosine 13 over negative 13 over 12. And cotangent would be 12 over 5. Right? Alright, that concludes this entire lesson. I kind of rushed through the video to get it done before class starts. I hope it helps. And I will catch you later.